So yeah, I think this talk is going to be a little bit of this talk is going to be continuation of the talk that I gave last year at Bakra. It was on recon as well, but last year I was talking about esoteric subdomain enumeration techniques, which was very niche topic. Like there are few techniques that not a lot of people use regularly that I found very useful. So I was covering them, but this time I'm going to cover a bunch of practical techniques. These are the techniques that I use day in, day out. I am not going to cover all the techniques. I'm going to cover few techniques that I think are a little important. And I tend to speak really, really fast. So if you feel that I'm speaking fast, just complain and I would slow down. Just to give a bit of brief about me, I like to personalize the person behind the screen. So I am Bharat. I am live from Bangalore in India. It's been raining here today, so it's a beautiful day. But it's middle of the night here. So in case if I sound a little dull, just blame it on the time. And I work as a security engineer at this company called as AppSeco, and I am an OSCP, just to put it there, because I cleared it a little like a year ago, but yes. So the other thing is that most of the techniques that we're going to cover today will involve DNS. So I have set up a name server, which is ns1insecuredns.com. And also there are a bunch of domains on that. You're free to try the attacks against these. I mean, only the attacks that I mentioned in this talk, not anything else. So this is the demo environment. I'm also going to put, this server is going to be up forever. So you can try this anytime you want. And the other thing is that there are going to be a lot of techniques in this talk, but I'm going to give a Git book, like a book that contains all the techniques that I'm going to cover. So in case you miss few techniques, don't worry about it. In case I'm a little too fast and you can't understand the technique, don't worry about it too much because you're going to get the reference to it and you can practice it later. So what is this talk about? How does it differ from the last year's talk? How does it differ from the others? I'm trying to put in a bunch of practical techniques here. So these are the techniques that you can just, when you talk about recon or OSINT, a lot of people cover a lot of techniques, but there are a few techniques that we don't use regularly in our pen testing. But I try to cover techniques that could be directly useful in our pen testing or security assessments. And the objective is to cover a lot of tools, techniques, and sort of tips and tricks if I have any. That's about this talk. So when we talk about reconnaissance, at least in this context, what do we mean by it? So by reconnaissance in this talk, I mean that it's an act of gathering intelligence on a target. Like if someone wants you to do a pen test, or if you're a bug bounty hunter and if you want to attack a target, you have either domain name or IP address and you want to increase your scope, or you want to find a bunch of assets that you want to attack and you want to gather intelligence around your target. This is because you want this information to plan an attack. So this is the important part. Whatever data that you get from recon, you want to use it to stage an attack. And it can be performed actively or passively. I usually care about active or passive when I'm doing a pen test or a security assessment. But for this talk, I'm not going to do any division between active or passive. Everything is just put out there. But the book that I'm going to give out will clearly mention what's active and what's passive. So when we do recon, like for a security assessment, what do we look for? We look for I categorize it into 4 categories. One thing that we look for is information to increase attack surface. Now we have a scope. Now you are given a domain or an IP address or a brand name, and you want to find out the information that will help you find more assets in scope. You want to increase the attack surface that's possible. One of the ways you can do it is you can find domain names, or you can find net blocks or IP ranges as we call it, and we can attack this, or you need this information. And the other thing that we look for is credentials. It used to be emails and passwords, but now we moved to a world where we use more token-based authentication, keys, APIs. So we look for that. And we look for sensitive information. Either it could be documents or either it could be any information which is considered sensitive for a business. And the fourth thing that we care about is infrastructure details. So if there is an infrastructure that is set up by someone, if you have a target infrastructure, you want to understand the details, like what technology do they use? What things do they use? You want to care about this. So I broadly categorize the information that I look for into 4 categories. And this is it. And this talk is going to revolve around this. So let's look at one of the things. The first thing that a lot of people look at, especially from a bug bounty perspective, is enumerating domains. I usually used to call it enumerating subdomains, but then I figured out enumerating domains is also very important. In this step, one of the most important objectives is you want to find or correlate all the domain names owned by a single entity. If you are targeting a company, organization, or if you have a domain name, you want to find and correlate all the other domain names. And Patrick Hudak, he writes fascinating blogs about recon. He has come up with this he has a very interesting way of looking at domain enumeration, where he talks about vertical correlation and horizontal domain correlation, where the vertical correlation talks about all the subdomains that you have a domain, and vertical correlation is finding out all the hosts or subdomains that belong to the domain. And horizontal correlation is you find out all the related domains to that domain. If you have something like google.com, you might want to find google.cz or anything else. But from a bug bounty perspective, it's probably a grayish area, like you want to find out your scope. You don't want to attack the related domains. We all understand scope, so we just need to keep in mind. But when you're looking from an attacker perspective, you want to look at vertical domain correlation and horizontal. It makes sense. I found it to be very useful to look at it this way. So just to start with, and the other part is subdomain enumeration. This is in the previous article, in the previous image, the way we're looking, subdomain enumeration is part of vertical domain correlation. This is where you have a domain and you want to find out all the subdomains that belong to it. So there are a bunch of techniques, a bunch of ways to do it. I mean, there is no brand new research here, but I just put together all the techniques that I've ever used. One of the basic techniques that you could use is you could use search engines, and search engines these days, the popular ones have advanced operators. Something like site. When you do site, you can find out all the subdomains that belong to a domain. This is very useful in doing a vertical correlation. So you are finding out what subdomains belong to your domain. But there is also this advanced operator that's supported in Google Ping. I haven't used it on others, where if you give it an IP address, it will tell you what websites or what applications are hosted on that IP address. This is very useful to do horizontal correlation, where you have a domain and they might be hosting other domains. So these operators are something important, but when you're using popular search engines, I think at least for the part where you do vertical domain correlation, tools like Sublister, TurboLister has taken care of it, have made it very painless. So if you have Sublister or TurboLister, they'll just go through all the popular search engines and they give you the results. You don't need to do this manually, but IP is something you might want to look at. This is also very useful to detect if the target application is on a shared hosting. So I usually look at it whenever I have a domain that I want to test. And using third-party information aggregators, there are a bunch of third-party aggregators out there. They store some sort of information, and you could use this information to find out domains. One of my favorites is VirusTotal, where they run their own passive DNS replication service. And whatever the URLs that VirusTotal sees, they save it in a data store, and you could just visit it. So whenever I'm giving my talk, whenever I talk about a technique or a tool, on the bottom I give the link where you could go, you could download the tool, and you could try it on your own. So VirusTotal is interesting. They have whatever the URL they see, they put it in a data store, and you could actually enumerate. They have an endpoint. You could actually go to the web application and you can find it. But I wrote a very simple script that will actually make a GET request, and you can get a bunch of information. Just to demo it, so I wrote a simple Python script. It's called VirusTotal, and you just give it the target domain, and you give the limit because this is another parameter that asks for. Let me say 20. But the interesting part about VirusTotal, why do I mention it, is I am not really sure how it works internally. But when I did subdomain enumeration on a same domain using different techniques, VirusTotal has given me results that other techniques failed at. I got some interesting results. So I always try to look at VirusTotal once when I'm doing subdomain enumeration. I make sure that I check VirusTotal. So we have a bunch of subdomains that are part of EFF.org. These are up. I mean, they might have a valid A record, they might not, but that's a different topic. And you can find the script at this link. So this is a simple script. You could even do it with web application, but using third-party services is the key. And the other interest, and a quick tip, whenever I'm doing some technique like this, like using VirusTotal or any smaller technique, I usually love to use shell functions. This is just sort of a simple personal tip or personal thing that I follow. I write simple bash functions. So these make it very easy. So if I go to my bash, so this is just a simple bash function that I put in my bash RC. So now I could just say EFF4. This is the same thing. I would get the results, but it just makes it much easier. I always found it that when I have this bash function, I tend to use it often rather than a script. This is just a habit. So I find it that using shell functions is much nicer. And the other third-party information aggregator is ViewDNSinfo. It's a very handy service if you want to do reconnaissance around DNS or who is related information. So if you have an email address of an organization, this is one of the things you could do with ViewDNS. You can do something called as reverse whois, where you give an email address and you can find out all the domains that are registered using that email. If you notice, I gave something like whois@aff.org, and there are a bunch of domains. These are registered with the same email. So this is horizontal correlation, which is sort of useful, but just to give a quick context, you might not get an email address. So interestingly, if you look at it, you do not get this email address. The whois@aff.org is not there, but I'm going to cover a bunch of techniques by which you can find email addresses. But this is the idea. If you have an email address, you could use third-party aggregators like View DNS Info, find out, do a horizontal domain correlation. And the other favorite, this is one of my favorite techniques. So there is something called a certificate transparency. So in the last few years, in the last half a decade, there have been just to give you context on what certificate transparency is. In the last 5 years, or in the last decade, there have been a lot of attacks against the certificate authorities, where companies like DigiNotar and Symantec, DigiNotar got hacked and they gave it. Symantec, I have no clue why they gave it, but they gave fraudulent certificates, fraudulent wildcard certificate for certain domains, which were used to snoop on people. But the idea is that these fraudulent domains, Google at some point realized that one fraudulent certificate, one wildcard certificate for Google, which is fraudulent, could just break the whole ecosystem. It's it could just break the whole ecosystem. So they figured out at some point they need to have certain standard by which they can actually secure SSL TLS ecosystem, and they came up with something called a certificate transparency. So the idea is very simple. If you're a certificate authority, if you're going to issue an SSL or TLS certificate, you have to log it into a log file, which is append only. They use Merkle hash trees, but I'm not going to get into the details of it. But the idea is that you have SSL, you are a certificate authority, you're going to give SSL TLS certificate. Now you have to append it into your log file, and this log file is going to be public. You could go to the link over here and you could see all the known log files out there. And I wrote a little extensively about certificate transparency at some point. You can read it in the blogs. I'm not going to get into the technical details of it. So the side effect of this, the idea is that if you're a domain owner, you could just go check in all the log files for all the certificates that are issued. If you have 10 certificates that you got for your domain, and if there are 15 certificates in your log files, you know that the other 5 might be fraudulent. So that is one of the ideas of certificate transparency. But the interesting point is that these log files are known log files. Anyone can look into it. So if you are an attacker, you could look into all these SSL TLS certificates. And SSL TLS certificates tend to have interesting information like domain names, subdomain names. They have common name, CN. I think you can get the domain name from there. And there is subject alternate name where they can just stack up a bunch of other domains. I mean, if some company is going cheap, or there are a bunch of reasons for doing this. You have SAN field where you have a bunch of subdomains. So SSL TLS certificates are interesting to enumerate domains and also enumerate the other interesting part. Like a lot of people overlook this. If you have a bunch of SSL TLS certificates, something that you could look at is the email address in the certificate itself. That's a very interesting place to look at. So this is the side effect. If you have now we have certificate transparency, attackers can just look at all the SSL TLS certificates that you got issued publicly, and they can enumerate the subdomains. How do you search through city logs? If you're a domain owner or if you're an attacker, the easiest way is browse to one of these websites. And these are the aggregators. They look into all the log files and they give you a nice interface to search these certificates. You could just put your domain name over here, for example. Let me just go to see what it does. So I do something like, this should give me a bunch of certificates. Or if it's way too many, I think it's going to take a while. You could just do something like that. You could do percentage. This is just a database notation. I think it'll take a bit of a time because I think they might have a lot of certificates. Let's just leave it there. But the idea is that you could go to these links. They give you a nice interface to search through. Something like this. CRT.sh is a Commodores project where they give you an interface. I search for some company and you get the certificates, and also they give you what domain the certificate is issued for. If you notice, there's something like Git, Jenkins. Luckily for this organization, they actually had proper authentication. But sometimes there are a lot of cases where there were a bunch of services that were open. And also there are two cases to this. Most of the time when you look at these domains that you have in this list, they might not be accessible over the internet. But when you're doing an infra pen test or when you're doing an infrastructure security, you might, once you get into their network, you might figure out that these actually work. These are the internal domains or internal services that they are running. So there are two levels to this. One thing is you could either get access to, you could look up a domain here and you could access it from the internet. Or maybe when you're doing an internal pen test, you could save this and you could try it once you get internal access. But this is the idea. And oh, I think I missed the script here. So we just wrote a, this is just a Python thing. So I wrote a simple script. So the other interesting part is, so crt.sh gives a PostgreSQL interface to the database. So you could just search all the queries using the Postgres database. I wrote a simple script around it. This is nothing fancy. I use PSQL interface and I want to find out all the domains of EFF.org. Yeah, that was fairly fast. And you get a bunch of domains. There's a lot of domains. That's one of the reasons why I think the web application hang. So now you use crt.sh, you get a bunch of domains. You could start checking if these have valid A record and you could just test. There are a bunch of interesting things. Yeah, Java, Kipano. But that is the idea. You could just do subdomain enumeration using ctlogs, either web application or you could use scripts. And the other interesting part is that Facebook is a massive proponent of certificate transparency to a point where they came up with this tool called a certificate transparency monitoring tool, where you could do the exact same thing we did with crt.sh. You give a domain name, you could find out all the SSL certificates. But the other interesting part is they have something called as subscriptions, where you could go put a domain name and you could give an email address. And whenever there is a new SSL certificate that gets generated for the domain that you gave, you get a notification via email. This is actually fairly interesting from a bug bounty point of view. Like if you have a domain that you want to talk about, you could just switch on the notifications, and whenever there's a new service, or whenever there's a new certificate that comes up, you can see it here. That leads to a domain name, and that domain name might have an application. So there are a bunch of other services that offer the same thing, like monitoring your logs, but monitoring the CT logs and getting it. But ideally, I think if you are serious about certificate transparency and if you actually want to find a bunch of things, running a certificate transparency monitor is not really complicated. You could run your own monitor on a AWS EC2 instance or something. You could just take a look. Also, there is a service called CertStream, which give you almost near real-time data. You should look at that service. It's called CertStream, or you could run your own monitor. I prefer to run my own monitor. I don't try to rely on third-party services. But this is how you keep track of an organization's subdomains. Could be interesting from a bug bounty point of view. But the downside of CT is it's an append only. CT logs are append only, and once you put some information in there, there's no way to take it out. For example, there's something like, if you look at the phone, shouldn't take so long. Yeah. So if you look at it, they have some interesting subdomain over here. They can never take this out. It's just going to stay there forever. It's just going to stay there. So the side effect of this is that once some subdomain goes into CT logs, it's going to stay there forever. Even if the company takes it down, if there's no subdomain, it still shows up. So that's going to give a lot of false positives when we do subdomain enumeration using CT logs. But one way to tackle it is you could use a tool like MassDNS, which is a very fast DNS resolver. You could use a command like this, where I'm using my script to get the subdomains from CT logs, and I just pass it to MassDNS with a bunch of options, and it gives me, and it resolves DNSs for these domain names, and it gives me which domains have a valid A record or CNAME record. This is a much easier option. You can reduce false positives using CT logs with MassDNS. This is one thing interesting. You could find CNAMEs and you could just follow that. This is interesting. And you could use a bunch of other services like CertSpotter. CertSpotter gives you, it's just the same thing like crt.sh. You could just use this bash. This is a bash function. You could use this to find all the subdomains. I don't have it here. It's just the same thing. But I'm just using a different service. It'll work. I think my internet is a little slow. So the interesting part is that when you did this, you are also getting a bunch of other information. This is not just vertical correlation. This is also doing a little bit of a horizontal correlation. Like copycrime.com, copycrime.org. Probably they own the service. There's EFF.com, which most probably is owned by EFF.org. So when you're using search portal, you can actually use this service to do vertical and horizontal correlation. So this is an interesting service to look at. And this is the command. This is just a curl get command, get request. And there is other service called a CertDB. You could use, so CertDB has an API key that you have to provide in, but the idea is that CertDB not only has CT logs, SSL certificates from CT logs, it also goes ahead and checks all the IPv4 address space to find out SSL TLS certificates, and it gives a list of it. I found that when you use CertDB, you find a bunch of other interesting domains which you can't find with cert.sh or search portal. This is a service that I would look at. You do something like this. Let me just, okay, you can just try this. CertDB.com. This is something I try because it gives me a bunch of extra information. In some cases it does. And this is a very interesting use case. So now that you have a real time, now that you have a way to monitor domains of an organization in real time, you could use it for a bunch of things. One of the things that has happened, this is a research that came out last year. So when you set up a content management system like WordPress or Joomla, there is this window of period where you don't have authentication for your application. So mixing it with, using it with CT logs. Now CT logs give you if you use HTTPS service for your CMS when you set it up, which is default for most of the CMSs. Now the domain name itself comes upon CT logs. So if you're fast enough, you can actually access the application in that window of period where there is no authentication, and you can take it over. This has been demonstrated by Hannenberg at DEF CON 25, and also it has been individually presented by HD Moore at Besides LV. I think a lot of content management systems have been patched for this. I'm not sure about it. I haven't looked into this research, but it felt like an interesting use case. Now we have CT logs. You could do a bunch of different things. I'll talk about a couple of other use cases later. And there's other service called as census.io. It's again like CertDB, but I find it to be a fabulous service. This census.io has it stores a bunch of data, but I'm going to talk only about the data of SSL TLS certificates. Again, it stores SSL TLS certificate that it finds in CT logs, and also it scans the IPv4 address space. This is a very good source for domains and emails. I think I wrote a service available. How do I do this? Okay, I'm just pedantic about using that tab. So I have a script that I wrote. I say Python and it census enumeration. It's available on GitHub. I say I want it to be verbose mode, and I pass in my domain names from a text file. So it just suggests I just want to point out something interesting. Then you do the search. So if you notice, I'm not looking for subdomains now. I'm looking for emails that belong to this. So it gave me a bunch of emails that we found as part of the SSL certificates. If you notice, you have who is EFF.org, have root at something. You don't worry about this, but and you got a bunch of subdomains as well, and it's going to search for the other domain. So the interesting part is you could not only find domains, you could find email addresses. These email addresses could be used to do a reverse who is search or a bunch of other things. But the idea is you have two things to look for in this instances.io. You look for emails or even CT logs. When you have SSL certificates, you have two things to look for. Look for emails and also look for domain names properly. And Patrick Chirac wrote a fabulous guide on Census Guide. It's called Census Guide on how to use census for recon. This is something to look at when you have time. And this is just a demo of the script in case you want to use it. The link for the script itself is given here. I usually run these things as microservices, but I'm just demonstrating the scripts. And the other interesting place, or a little overlooked place for domains, is CSP, Content Security Policy. Content Security Policy lets you define a header called Content Security Policy HTTP header. This allows you to whitelist a source of trusted content. Like if your application wants to execute or render certain content or resources, you whitelist these things using CSP. So when you talk about whitelisting, you are actually putting some sort of domain names in your CSP header. So this is actually interesting. You could ideally use it. Subdomain enumeration, I'll just do a quick CSP parser, and I just use it's a popular e-commerce site in India. Okay, if I do this, it just parses, it's nothing fancy. It just parses the CSP header and gives me all the domains. I could just take a look. If I search for flipkart.com, now I know that they also own Flipkart. So I did a horizontal enumeration. I think if I give -r, I've wrote it a while ago. So yeah, if I do it a -r, it just results and it tells me what is the domain and if it has a valid area code. Few of them don't have a valid area code. These are something interesting. If they don't have a valid area code, maybe you might want to look at if they are registered or if they're owned by someone. So the idea is finding subdomains using CSP header. And why is it important? Because you might end up with attacks like this. This was from a couple of days ago where a popular CDN had a vulnerability where you can write arbitrary files onto it. But you could think about it even in an individual case. When you have subdomains here in your CSP header, and you find some vulnerability on that, you could probably use that vulnerability on the third party to execute JavaScript or anything on your primary domain. So CSP headers are one interesting place to look at. And also there's this other thing called a sender policy framework. We're talking about DNS now. This is a DNS record. So simply put, SPF record says that these are all the values in SPF record are the hosts that are allowed to send an email on behalf of a domain. If someone receives an email from a domain, something like ican.org, your email client could look up all the hosts that are given in SPF record for the domain, and it will be sure that and it will make sure that it receive email from a legitimate host. So SPF record is a way of telling that these are the hosts that are authorized to send email on my behalf. But the interesting part is, if you look at it, you have a bunch of subdomains here. Like say, I checked for ican.org, and there is something like Salesforce ican.org, and there are also a bunch of IP ranges here. From these IP ranges, you could probably enumerate a lot of information. This is an interesting recon technique, especially from an infra point of view. From an application point of view, if you have a subdomain over here, you could just do something. Let me just see if I have a script for this. Okay, yes, I do. Let me just do. I could just use anything. Okay. That's just a Python thing. What is it? I don't have my libraries. I'll just do the demo then. So this is just a demonstration. I could just run the script, but I forgot where I installed my scripts. So you could just, the script is available. The link is over here. So you could just say domain, and it will pass the SPF record and gives you your domains and IP addresses. But if you say -ASN, it goes ahead and gives you the ASN information of all the assets. It finds an asset in SPF record, and it gives you which ASN does it belong to. So you might want to know who owns the block. You might want to know that. So this is something you could do. And also domain enumeration using DNSSEC. Just to give you a context to this, there is something called a zone transfer attack in DNS, where a master server is giving a zone file to a slave server. But if you misconfigure your zone transfer settings, the misconfiguration might lead the server to give zone file to anyone. This is called a classic zone transfer attack, which you can't find a lot anymore. The way you do it is you could just say AXFR, which is a DNS transaction. I am running it against my own name server. I did not. Yeah. So this is the attack. It's basically not an attack. It's a technique. It's just a misconfiguration that you are exploiting. So I want to do a zone transfer. This attack is against a name server. For this name server, I'm asking for a zone file for this domain, and I get the zone file. Ideally, it should give some. If it's securely configured, it should give something like this. The transfer should fail. But this is zone transfer attack, and we used to love this attack half a decade ago. It used to be very prevalent, and it was a fabulous attack because you could get all the domain names. And the interesting part is, because it's a zone file, most of these domains are valid. You have a record for these. And when DNSSEC came up, we sort of, when the name servers of DNS like bind and all this, when they came up with fairly secure defaults, we missed DNS zone transfer because most of the public name servers were patched. You would still find DNS zone transfer in internal domains, but we missed zone transfer. But when you talk about DNSSEC implementations have something called as authenticated denial of existence. It's a fancy way of saying if someone asks for a subdomain that doesn't exist, how does the name server answer? This is a little technical. I'm not going to get into the details. So the way the name server will deny the existence in DNSSEC is using two records. There's NSEC records and there is NSEC3 records. So the idea is that if you're testing something if you're testing a target that has DNSSEC enabled, just try to use tools like, I use LDNS walk. It's part of LDNS utilities. Let me just save some time. So I'm saying LDNS walk and I am running it against the name server for a domain. If I do this, because this domain has DNSSEC and it has been configured with NSEC records, it is vulnerable to something called as zone walking. So when you ask for a non-existent zone, your DNSSEC implementation has to tell you what is the next valid domain. So you are using it. It's like a linked list. You are finding out one domain and then you're asking for the next domain. You make a linked list of things and then you just find out all the domains. This is a fairly valid attack. If you have DNSSEC implementations, especially if you are doing a security assessment against government agencies or something like that, where they need compliance, they might have DNSSEC and you might want to test for this. You use LDNS walk and you just say name server and domain, you could get this. But ideally, if the way it should be configured is, there's another. So if I do this, I actually configured this zone with NSEC3. This shouldn't, now the attack is not working. This specific attack is not working. So if you're, the key takeaway is that if you're testing something, a target which has DNSSEC enabled, try this attack. If it has NSEC, it will give you all the domains. So we used to love zone transfer, and now in the DNSSEC world, we got our most favorite attack in the form of zone walking. So this is how you install LDNS utilities, and you can just try it out. The interesting part is people thought that it's actually a vulnerability. NSEC is still vulnerable. So they came up with something called as NSEC3. The only change is that in NSEC, you store your zones in plain text. In the zone file, everything is in plain text, but in NSEC3, you just hash your domain name so that people, in the expectations that people don't find it, and you also use salt, but the salt is constant. If you look at it, the salt is constant and you have a hash. But the idea is that an attacker still can collect all the hashes and he can crack it offline. I'm not going to demonstrate it, but you can just try it. It's effective. If you have decent amount of computation, you can just do this. So there are tools like NSEC3 Walker, NSEC3 Map that can automate collection of hashes and also cracking these hashes. For example, this is how you use NSEC3. So you say collect, it's a script, and you give the domain name. It's going to collect all the hashes for you. After this, if you have enough, you can take this file. Now it's offline. You can take this file and you can crack it at your own leisure. If you have enough computation power, you can crack enough hashes. So when I did it for ican.org, so if I do something like this, just to prove a point. Yeah, it says NSEC3 is what is being used. So now I started collecting all the hashes and then I started cracking the hashes. So I ran it for like hardly 5 minutes on my laptop and I could crack a bunch of things. So this was supposed to be, so when they used NSEC3, you're pretty sure that they're trying to hide the subdomains, and now you could actually crack it. I'm not sure, I'm not suggesting any legality around it, but this is just a valid attack. If they're using NSEC3, you can still crack the hashes. This is not really so secure. And there's a new implementation called NSEC5 that is supposed to make the zone file, the DNSSEC implementations secure even against attacks like these. But I haven't looked into the standard itself. Something, this is how you install NSEC3 Walker. And there are a few other recon techniques that we'll talk about. So with the advent of API world and with the advent of DevOps, there are a few things that changed in the way that we do things. The things that changed are the way we do storage changed. The way we do authentication changed. We used to use Google username and password. Now we use API keys, token-based authentication, and people started writing more and more code. There is infrastructure as code, a bunch of other things. It's all code now, and there are CI/CD pipelines. So these are a bunch of things changed. How does our attack surface or recon change? So one thing, when you talk about storage, cloud storage has become so popular. So especially object storage has become popular. Object storage is where you can just store static unstructured data files on a Ideally, now they store it on a third party. Few of the most popular ones are AWS S3 buckets. And recently, DigitalOcean Spaces, like they always do, AWS came up with something, and DigitalOcean Spaces just came up with the exact same kind of a thing. So we have S3 buckets, you have DigitalOcean Spaces. There are a bunch of other services that I'm not covering, but this is the idea. Cloud storage has become all the rage. Like object storage is, people started putting log files, backup files, everything on S3 buckets. So what's the catch with object storage? Now that object storage is good for storing anything, especially static files, people start putting everything like plain text files or pictures of their pets, log files, backup files. We have seen everything on S3, open S3 buckets. So Amazon S3 buckets is fairly popular. Amazon AWS S3 or Amazon S3 is a service provided by Amazon, where buckets is where you can store a large amount of files. So is it a relevant attack? I mean, in AWS S3 has made buckets by default private. I wouldn't think that it would be a viable attack, but surprisingly, it has been proven. We have been proven wrong multiple times. There are a bunch of attacks in 2017 against large companies that have happened only because of open S3 buckets. I mean, I would never think this is a really serious one. I would never think this is prevalent, but the historical data has been proving us wrong. There's a bunch of other validations for S3 buckets misconfigurations being a real viable attack. So hunting for buckets, the interesting point is that every bucket has a unique URL. So you can just go to that URL. You can just find out if it's a public or a private bucket. And you can just see the access settings. If it's open, you could just download the files. It's a vulnerability, basically sensitive information exposure. Point just mapping it back to the things that we are looking when we do recon. So Amazon S3 buckets have this specific pattern where they end with S3 Amazon.com. So you could use good old Google Docs to find stuff. If you just do file password, file PDF, you could just find a bunch of PDFs with interesting information. I mean, these are a little, I understand these are a little old. And this is also like carpet bombing. You are not targeting a specific organization. You're going on the internet just finding random stuff. But this is something that people can do. And the other interesting part is if you are targeting a specific organization, you could use tools like AWS Bucket Dump, or my new favorite tool is called LevelUp. It's written in Go, and it's a fabulous tool. The kind of especially the interesting part is the kind of permutations it tries. I think I have a demo for this. Yeah, you could just do slurp. It's a binary, so I won't run binary with a keyword. It's just a company. It's just a random company in India. So we want to find out all the S3 buckets that they have. So if you notice, it's fairly fast. It's finding all the subdomains. Do these buckets belong to the company? I'm not sure. There's no way to tell. But the idea is that you find a bunch of interesting information. So Slurp is a fabulous tool for two reasons. One of the reasons is it's written in Go and it's fairly fast and it finds it. And the other, so just to go on a tangent, this is not actually a vulnerability. These are forbidden. These are not private buckets. So this is a fairly secure case. But the idea is that you can find buckets. And the other interesting part with, I think with Slurp is you could do something like search tree, I think. Yeah, when you do search tree, Slurp is going to go find out all the domains that pop up in CT logs using this service called a search tree. And it tries all the permutations around this domain name. So you have a domain name that pops up in CT logs. Now, Slurp has a bunch of permutations. It starts looking at all the permutations around that domain name. So if there's an open bucket, it will give it to you. This is a very interesting thing. It's sort of like automating bug bounty. Now, if you have a bunch of companies that are in scope for your program, you could just take a look at it. If they have domains, you could just start looking at the domains popping up on CT logs, and you could connect it with this. So you can find sensitive information if they have it open. It's sort of a corner case, but still something you might want to look at, because I've found a bunch of companies that had sensitive information upon buckets using these techniques. Nothing serious, but a viable attack. And the new service, just to talk about the other service, there's something called DigitalOcean Spaces. So basically, it's exactly like S3 buckets, except that the bucket is now called a space, and it's owned by DigitalOcean, and it's API compatible with S3. So you could just use all the tools that you used to work on AWS S3, and you could just change a bunch of parameters because this API compatible, and you could just run it against spaces, and the same attacks continue. Whatever you used to do with S3 buckets, the same attacks continue with spaces. It's just that spaces is a new service, so people might still be figuring out how the secure defaults or secure configuration works. So this is something you might want to look at. So this is a public bucket. It's just giving you all the file details. This is how a private bucket will answer. It's just saying access denied. This is exactly how S3 buckets work. The interesting part is I just wanted to find out, I was just doing some sort of internal research on Spaces. I wanted to find out how prevalent it is. So I figured out that Spaces is API compatible with AWS. I took this tool called as AWS Bucket Dump, and I just changed like hardly 10 or 15 lines of code. Now it works with DigitalOcean Spaces. So it's called Spaces Finder, not really creative, but whatever works. So basically, this tool is something you can just run it against. You could basically run a dictionary attack against a domain, and you can find out all the public buckets there. The tool's output looks much better these days. This is a screenshot from a few months ago. But this is the idea. You can attack storage this way. S3 and Spaces are just two services, but there are a bunch of other ways to attack storage. And we also want to look at authentication. One thing is, in authentication, you want to find out, in the old school way, you want to find out emails and passwords. So I've given you a bunch of techniques where you can find out emails, especially the emails that you get out of SSL certificates and stuff. They could be sort of interesting because this could be key people in the organization. And passwords, you could probably find it from data dumps, which I'm not going to get into. But that is the idea. You can just crack that sort of an authentication using those techniques. But the other sort of authentication is using APIs, tokens, keys, which is all raised these days. But the problem is that the way API keys are used, there are a few people who use the time to live for APIs is long. There are a bunch of things. So token-based or key-based authentication, if done wrong, could prove vulnerable. But the interesting idea is that now that we are using something like APIs and keys, you're putting everything in your code. Like if you're developing securely, if you have proper development culture, it's all okay. But if you don't know what you're doing, you might end up putting your API keys everywhere. So that's where we get to something called code repos for recon, because code is where everything stays these days. So code repos are treasure trove of information while doing recon, especially these days. Code repos can reveal a lot of information, credentials like old school usernames, passwords, API keys, and also a bunch of infrastructure details. You can find out what technology they are using. So this is just a random tweet that I found. Like you do Deloitte on passwords, and you have like 614 hits. I'm not sure if they all work. I haven't tested it, but there's something to look at. If you put organization and if you're putting password, you have hits. It's sort of bad. I'm not saying they're vulnerable, but it's sort of bad. So GitHub for recon. GitHub is one of the most popular version controlling version controlling platform used, and a lot of code is there on Bitbucket. But try not to forget GitLab and Bitbucket. Those are also fairly popular, and people put a lot of code in there. So Ed Overflow has written a neat little guide that is GitHub for bug bounty hunters. This is something you should look at. Most of the information that I'm going to cover is based on that article. But the thing that I like is GitHub has a very nice REST API where you can automate your recon. If you are targeting an organization, you could use GitHub's API to automate all sorts of recon stuff. So when you're looking at code, especially on GitHub, there are 4 places to look. This is sort of important because people miss out on certain things. One thing is you look at repositories, like a person owns some repositories or organization owns some repositories. This is something you should look at. I think I should also put people here. That would be the 5th parameter that you might want to look at, especially when you talk about organizations. And also, so getting back to this, you want to look at repositories, you want to look at code, and you want to look at commits. This is my favorite. Like, not a lot of people understand how Git works. One of the most important things I learned about Git is that Git never forgets. You put in something there, it's going to stay there. And people have a hard time understanding this concept. So you want to look at repos, code, commits, and issues. This is another favorite of mine. So just to give you a bunch of examples, the commits, my favorite. So there's a commit that says delete the private SSH key. There is something wrong about this. Well, they don't understand how commits work. It's just going to stay there forever. I mean, this is just a very simple example. I have found horrible stuff in commits. I mean, there was this point where I have committed random secret to my GitHub Git itself. That's when I figured out there's something called commit history. We all do that, but we need to learn and evolve. But this has been a vulnerability. That private key has been used for a bunch of services. I've figured out using different recon techniques. It was bad. And the other things that you want to look at, issues is something I really love. So you have SQL injection of vulnerability in data views, bunch of things. You look for a vulnerability, and you can just find out a bunch of repos and code that has these vulnerabilities. And a lot of these are not fixed. These are not popular software, but still you have an application, someone raises an issue, and it's just there. sort of maybe if it's a serious security issue, maybe you might not want to report it using issues. Maybe that's something that people who report should think about it. If it's a security issue, maybe you want to communicate with the person who wrote the code first, not just put it publicly out there. But this is something interesting to look at from a recon point of view. And mask cloning on GitHub, you could use, there is a GitHub cloner where if you have a organization or a person, you could just mask clone the code. Now you have all the source code and you can just start doing some reconnaissance around it. My favorite, I use static analysis tools, especially if it's code like Ruby. I use Brakeman. For Python, I use Bandit. For all the other software, there are a bunch of tools where you can do security analysis. This is an easy win. You have code repos. Now you just run these tools and you find out possible security issues, which might lead you to finding other vulnerabilities. So static code analysis is something I look at. You find people or you find organization, you find their code hosted, and you do some static analysis. And don't forget that you could do manual search. Just look for all the possible keywords that people might name things with APIs, keys, tokens. And I sort of forgot to put the slide here. You might want to look at tools like TruffleHog, which will find out the secrets in a code using entropy. And there's also other tool called as Git All Secrets. It's basically a Docker container. It's basically a set of Docker containers that use a set of other tools like TruffleHog to find out secrets in your code. You might want to look at these things. I mean, manual search is something I do first, and then I go for tools like TruffleHog, Git All Secrets, bunch of other things. So you have code, you want to find secrets. This way you do static code analysis where you want to find out vulnerabilities in the source code itself. Here you're just finding the secrets. I've found a bunch of secrets that people put up in source code everywhere. This is just something interesting that you want to look at. And there is something called GitHub Docs, like Google Docs. You have a bunch of GitHub Docs that have been posted in these links where you could just go. So GitHub has a very powerful search feature, so you can use these GitHub Docs to find something interesting. So these docs are security focused, so you might want to take a look at this. And coming to the last topic that I'm going to cover, this is my favorite topic. It's called reconnaissance using public data sets. So there's a lot of security research going on around the world, and there are a bunch of security researchers who are putting up open data for the community to use. And this data is the data that includes port scans, DNS data, SSL TLS certificates. For example, census.io user does this. And CTLogs itself is an open, I'll consider it like an open database. And even data breach dump details, the legality around this is something I'm not going to comment about. But looking at it, this is all open data that's available and you can use it for recon. But the problem is that this is like finding a needle in a haystack. You have a specific organization you want to target out and you have like 10 gigabytes or 10 terabytes of gigabytes is easy, but 10 terabytes of data that you want, but you want to look at specific information about specific targets. This is like finding a needle in the haystack, but this has been one of the most effective techniques I have figured out that this is very effective. So why do I use public data sets for recon when I have all the third-party services that does the job for me? One of the most important points that I always emphasize is to reduce the dependency on third-party APIs. If I'm doing a security assessment, I don't want all the third parties to know that I'm testing security for some company. People call me a little paranoid for this, but I wouldn't want all the third parties to know. If I'm testing some application, I would want to keep it to myself. So not the bug bounty part of it, even security assessments. I wouldn't want everyone in the world to know that I'm testing some application. So if you have open data, if you have data sets for yourself, you could search them and you don't need to reveal any information. But also you want to reduce the active probing. For example, DNS generates a little bit. If you are doing DNS recon, you are asking target names over for certain things. It's not really going to raise any red flags, but you might not want to do that. You might not want to actively probe. When you have offline data, why would you want to go probing? So you might want to do it passively. That's one of the other interesting thing. And you want to do better coverage because most of this open data is historical. It's going to stay there forever. So it gives you a lot of coverage. You can historically see what has happened. There are a bunch of open data sets. If you look at the data, if you look at these data sets, I think I'll probably update the Gitbook with these details. So these data sets, when you look at it and when you analyze it, you can actually get a proper coverage on the history of an organization. You could understand how the infrastructure has been changing over the time. So this is something you should look at. And last, and my favorite reason is, if you have open data, you can just build your own recon platforms. I think HDMore has done a fabulous job, and besides LV 2017, on building your own recon platforms using open data. This is my favorite. So this is from HD Moore's talk. He talks about a bunch of public data sets that are available. I just put this for you to look at. So I'll just talk about one such data set. There's a data set called as FDNS data set. There's also RDNS data set. This is by Rapid7. So Rapid7, they store it on this website called scans.io. I think I have a link. No, but the website is scans.io. So this database is massive, 20 plus GB compressed. Uncompressed it is on. So the last time I uncompressed it was around 300 plus, but when I went to the end of it, it's around 600 GB, I guess. So this data set aims to find out all the domains that are on the internet. I think they do DNS any query, and they do a bunch of other DNS queries all across IPv4 address space, and they record it in a database. So essentially, this data set, which is massive, has knowledge about all the domains found on the internet. This is a gold mine. So how do you search it? There are two ways to search it. It's free to download. This data set is free to download. You could just do curl against the website itself, and you could just get, because the format itself is in JSON. I use Pixie, which is fast. It's faster to uncompress the data, and you could just take a look, because the data itself is JSON. I'm using JQ to parse it, but the idea is that you could just download it. But a better or efficient way is to just download the data set and start looking at it. There are a bunch of techniques by which you can actually, you don't need to do this. This is a very slow process. You have the data set. Now you're using some bash commands to look into the data. This is not very effective. It's a little slow. If you are doing something like this regularly, you might want to look at, there are a bunch of techniques by which you can build data structures around this, which make it fast, which make the lookups really fast. You might want to probably check out HD Moore's talk around this topic at BSET where he talks about how do you make faster lookups. But this is a fabulous data set. Not just this, scans.io I was talking about, the data on this website is fabulous. You could just find all sorts of information over there. This is something you should look at. So this is just the most rudimentary process of how do you find domains of an organization when you have FDNS data set. It has proved to be very, very successful. This is just a subdomain enumeration cheat sheet I have. I have posted that last year as well. I think we are sort of at the end of the talk. But just to give you an example, I started using these techniques. So just the subdomain enumeration techniques, I started using it against a bunch of domains. So just to give you an example, I started using it against ican.org. When I used sublister, which this is a tool that searches all the domains on a search engine, it found 258 domains. When I used ctlogs when I found subdomains that are part of ctlogs, there were 46 for ican.org. When I did zone transfer nsec3, I ran it for like few hours on my laptop, and I found 182 domains. It was nsec3 protected, not nsec. If it was nsec, I could have got all the domains. And when I used FDNS dataset, the interesting part is I found 3,681. So sublister sort of finds only the web applications or whatever is indexed by the search engines. ctlogs, the context is that you find domains that have SSL certificate on ctlogs. Rest everything you can't find it. Zone walking, well, it's nsec3 protected, so it depends on your computation power. If there's a domain that is named very unconventionally, you can't find it. But FDNS dataset doesn't have those restrictions. It's just a host somewhere. It's just a host sitting on the internet. There's no restriction of SSL certificates to be there or application to be hosted. It could just be an SMTP server or any server. So if you're doing an infra security assessment, like an infrastructure security assessment or something like that, FDNS dataset or open data is something that you should absolutely look at. This is my favorite technique. So I think we are at the end of the talk. I wanted to cover a bunch of other things, but I figured out that time might be a constraint. So all the scripts that I mentioned about, there are more scripts. All the scripts are here. The slides are going to be, I'll put up the slides in a PDF format there in like an hour or something. But this is where the talk material is. And a quick takeaway, I wrote a simple Git book on subdomain enumeration. I can find it over here. We have books. We have a books folder where we have a bunch of books that we wrote. And you could just, the first book is The Art of Subdomain Enumeration. I will update this book with a bunch of other techniques as well. But you have a book here. You could just go through it in your leisure. It's no groundbreaking research over there, but I just aggregated all the techniques. So a bunch of references that I use. And just to talk about my company, we do we do pragmatic, holistic, business-focused approach. So the idea is that I have done most of the research in my company's time, so it's only fair to mention the name. And that's it. We are at the end of the talk. If you have any questions, you can ask me, or I'll be on the Twitch channel for a while. You can just ask me any questions that you have.